Good evening, children. Welcome to Akshara IIT Foundation. This is Srinivas, your maths faculty. Welcome to today's class. Actually, today we have to discuss second synopsis of this quadratic equation, but we left two problems. Let us continue the problems, then we go for the synopsis too. Okay? Right. See, 20th problem, it is already completed, right? So this is all completed in your previous class. Yeah. So we have to start from 26th question. Let us see the coefficient of x. Coefficient of x. Before that, what is the given quadratic equation? That is nothing but x square plus px plus q equals to 0. In this quadratic equation, what is the coefficient of x? Right. Coefficient of x is p. Right. X square coefficient is, very good, 1. X square coefficient is 1 and the constant term is q. From this given quadratic equation, x coefficient p, right? Now here discussing about coefficient of x only. The coefficient of x in this quadratic equation, x square plus px plus q equals to 0, was taken as 17 in the place of 13. That means the p value we have to take it as 13, but by mistake it has taken as 17 it seems. So until then the p value is 17. Am I right? The coefficient of x is taken as 17 in place of 13. If you take 17, its roots were found to be, and the roots are minus 2 and minus 15 it seems. Roots means one of the root we are taking as alpha, second one is beta. It is minus 2 and minus 15 it seems. Then what is the product of the roots of original equation? Original equation means the value of p, nothing but the coefficient of x, we have to take it as 13. Okay, no? Right. So actually, if the roots of a quadratic equation alpha and beta are given, what is the quadratic equation? The form is x square minus alpha plus beta into x plus alpha beta equal to 0. Okay, that means alpha beta are roots. The quadratic equation general form is x square minus alpha plus beta into x plus alpha beta. Let us substitute the roots alpha value and beta value in the given quadratic equation. Before that, find the sum of roots alpha plus beta. Alpha value minus 2 plus beta value minus 15. Right. What is the answer? Minus 17. Minus 17. Now alpha into beta value. Alpha value minus 2. Beta value is minus 15. Now minus into minus become plus, 2 15s are 30. Now the quadratic equation is x square minus sum of roots alpha plus beta. That means in the place of alpha plus beta, we should write minus 17. Okay. Now I am writing minus 17 into x plus alpha into beta. Alpha into beta value 30. Okay. Now check x square, here minus into minus plus 17x plus 30 equal to 0. Once observe this quadratic equation, x square plus px plus q equal to 0, x square plus 17x plus 30 equal to 0. Compare these two equations. Compare these two equations. P value 17. Q value is 30. Am I right? X square term, first term x square term, here x square term both are same. Next px, that means p value 17. Qx, q value is 30. Okay na? Right. So q value is 30 by comparing the both equations. Now the question is, what is the product? What is the product of roots of the original equation? Let us write the original equation. What is the original equation? X square plus, I am not writing x term, you should tell the x term. Because in the place of 17 we have to decide. In the place of 13 we have to take 17. We have taken 17. That means 13 we have to write as it is, no? So it is 13x. This is original equation. Product of roots we have to find. But we don't know the roots, no? While you taking 17, we know the roots minus 2, minus 15. But here 13 is there, no? We have to find the roots. No need. No need to find the roots. Without finding the roots of alpha, and beta, we can find the product of roots. How? Yes, very good. What is that? Product of roots equals to constant term by x square term. We have formula, no? Product of roots equals to c by a. Sum of roots equals to minus b by a. Am I right? In same way, product of roots c by a. So 30 by a value is nothing but 1. So 30 by 1 is nothing but 30. So product of roots of the original equation is 30. If you take p value 17, got the roots. By using the roots, I have found out the quadratic equation to find the value of q, because here two unknowns are there. One is p and second one is q. P value already given 17. By using the 17, we need to find the value of q. Okay, na? That q value we should substitute in the original equation, that is x square plus 13x plus 30 equal to 0. From that we can find the product of roots. Okay. 27th one. Alpha, beta are roots of, this one is x square. Alpha comma beta are roots of x square plus x minus 1 equals to 0. X square plus x minus 1 equal to 0. Then alpha minus beta whole square. Alpha minus beta nothing but difference of roots. What is the alpha minus beta formula? Alpha minus beta, difference of roots. So that is b square root over b square minus 4ac by modulus of a. Okay, na? Right. Now we have to find this alpha minus beta whole square value. Let us find that alpha minus beta value first. That means I am comparing the given quadratic equation with general form. What is that? Ax square plus bx plus c equal to 0. A value nothing but x square coefficient 1. What is the b value? X coefficient. Here also not there anything, means 1. Constant term c value minus 1. Okay, no? So given quadratic equation, I am just comparing with the general form. I have found the values of x square coefficient, x coefficient and constant terms. Substitute root over b value 1, b square means 1 square minus 4ac. A value is 1 and c value is minus 1 by modulus of a means 1. This is alpha minus beta value. Okay, that equals to root over 1 square means 1 only. Here minus into minus plus, 4 ones are 4. Denominator we can eliminate because denominator is 1 now. So root over 1 plus 4 is 5. So I found the value of difference of roots is root over 5. But we need to find alpha minus beta whole square. What is that difference? Root 5. Root 5 whole square. Square root cancel. Our required answer is 5. Okay, na? You should remember this formula. We have already discussed so many times in our previous class. Difference of roots root over b square minus 4ac by modulus of a. Okay? Now please note it. Here synopsis 2 starts. Here onwards. So that is nothing but it is given about the properties of a roots of a quadratic equation. Properties of the roots of a quadratic equation. Okay, now let us see the first property, this one. If A and C is means we should compare with general form ax square plus bx plus c is equals to 0. This is the general form of a regular quadratic equation. A value is nothing but x square coefficient, b value x coefficient, and c value is constant term. Okay. Now see, if A and C are having same sign, that means if A value is positive, we have to take C value also positive value, positive integer, positive rational number, whatever. Same way, if A value is negative integer, we have to take C value also a negative integer. Clear? Both must be same symbol or same sign. Then product of roots formula C by A, right? Product of roots is positive value. Product of roots is positive. That means A value and C value, x square coefficient, constant term, both are same symbols. Whether they can be both are positive symbols or positive integers or negative integers, the product of roots is always positive. Product of roots is positive always. Let us see one example here. For example, 3x square minus 5x plus 7 equal to 0. What is A value here? 3. A is nothing but x square coefficient. 3 is positive 3. And C value is 7. What is the product of roots? Product of roots formula. Constant term by x square coefficient, right? Constant term is 7 and x square coefficient is 3. So 7 by 3 is a positive value. Same way, minus 3x square minus 5x minus 7 or plus 5x minus 7. See x square coefficient here negative 3. Constant term negative 7. Then product of root C by A equal to constant term by x square coefficient. Here minus minus cancel. It is 7 by 3. 7 by 3 is also a positive number. Okay, na? So for an example for x square coefficient positive as well as constant term also positive and the product of roots is positive. X square coefficient negative and constant term also negative and the product of roots also positive. That means if A and C are positive symbols or A and C are negative signs, then the product of roots always positive. Product of roots is always positive. Okay, na? Next. Second one. If A and C are opposite signs, that means if A value, if you take positive, C value is negative value, then product of roots is always negative. Okay, na? Check A and C are opposite signs. A and C are opposite signs. Then the product of roots is negative. That means C by A value is negative. So here also we can take an example. 5x square plus 3x minus 4. Here a means what? X square coefficient is positive 5. Constant term is minus 4. So a value positive, c value negative. Then what is product of roots? C by a. Product of roots formula C by a. Sum of roots formula minus b by a. Okay? Right. Now substitute C value minus 4 and A value is 5. Minus 4 by 5. That means we can write minus of 4 by 5. So this one is a negative value. This one is a negative value. If you take reverse, that means A value negative, constant term is positive. I am just interchanging minus 5x square plus 3x plus 4 equals to 0. X square coefficient is negative this time and constant term is positive. Now product of root C by A equal to 4 by minus 5. So actually we should not write the denominator in negative. So we have to write the minus symbol is in positive. So 4 by 5 minus 4 by 5 is a negative value. Got it now? So until then you have discussed two properties. A and C are same sign. Then product of roots. I am just discussing about product of roots. I am not discussing about sum of roots. So product of roots is always positive because A and C are having same sign. They can be positive or they can be negative. Now coming to second property, what? A and C are opposite sides. A and C are opposite signs. Okay, that means A value positive, then automatically we have to take C value is negative. If C positive, A value negative. Opposite symbols are opposite signs. Then product of roots is negative. Got it? Right. Yeah, before that, let us revise that if ax square plus bx plus c is equals to 0 is a general form, right? I think very initial stage we have discussed about this concept, right? While you are drawing the quadratic equation in graph sheet, that graph will gives you the shape of parabola, right? Parabola. That means it is open upwards. And here also you can take like this, open downwards. Whenever you take A value is negative, A value is less than 0, negative, we will get the parabola is in the form of open downwards. Or minima, maxima we have discussed, right? You remember or not? Right. Next. Now coming to the, if A plus B plus C equals to 0, then the roots are 1 and C by A. 1 and C by A. For example, in general form ax square plus bx plus c equal to 0. A plus B plus C, that means coefficients, all the coefficients, x square coefficient, x coefficient, constant term. If we add all of them, you will get the root. You will get the roots are 1 and C by A. 1 and C by A. Here, it is very, very important. For example, 3x square minus 5x plus 2 equal to 0. Actually, to find the roots of a quadratic equation, we use factorization method, right? Like splitting the middle term is a one method, or otherwise we are using the formula, quadratic formula. What is that? Minus b plus or minus root over b square minus 4ac by 2a, that formula. Okay? Or completing square method also we can apply. That means the given quadratic equation we have to convert as a plus b whole square or a minus b whole square formula, any one of the algebraic identity formula. There are three ways to find the roots of a quadratic equation. But here see, by using this statement, by using this property, we can find without doing any one of them. We can directly write the roots of a quadratic equation. Okay. See, for example, I am taking this only. What is the a value here? Very good. A value is 3. B value minus 5. Yeah, B value is minus 5. C value is 2. Let us check. A plus B plus C is 0 or not. A value 3 plus B value is minus 5 and C value is 2. I am adding the positive numbers. 3 plus 2, 5. 3 plus 2, 5. These two. And here plus over minus is minus. 5 minus 5 is 0. 5 minus 5 is 0. So, the condition is satisfies for this quadratic equation. Am I right? This condition a plus b plus c is equal to 0. Then the condition is satisfies here. Then what are the roots here? If a plus b plus c are 0, always one of the root is 1 and the second root is c by a. Second root is c by a. So therefore roots alpha equal to, therefore the roots, or you can write directly roots are 1 and c by a. 1 is a value, so c by a. C value means what? 2. A value 3. 2 by 3. Therefore, the roots of a quadratic equation are 1 and 2 by 3. Check. We are not splitting any middle term. We are not applied any quadratic formula. We are not applying any completing square method. Even though we can find the roots of a quadratic equation when the condition should be satisfied. Very, very important this one. Condition should be satisfied. Okay, na? Now, I will give you one example. For this example, you need to find the roots. Okay, na? By the same statement, you check whether a plus b plus c value is equals to 0 or not. Then find the roots. Okay. So that is 5x square minus 3x, 5x square plus 3x minus 2 equal to 0. So this is the quadratic equation. First, the condition is satisfying or not, you just check, then tell me the roots. Okay. Come on. I think it won't take more than 1 minute. In your mind, you can calculate all of them. You can add just addition only, no? Addition. If it is satisfied, then apply the formula. One of the root is 1 always. Tell me the second root. Yes, the condition is satisfied here actually. Am I right? Satisfies or not? No. It is not satisfying. So we cannot say the roots. Because see, a plus b plus c value. A value 5, B value is 3, 8, 8 minus 2, 6, but we should get 0, we should get 0, now you do it, now I am changing it here, you do it, now find it, the equation is 5x square plus 3x minus 8 equals to 0, check. Yes, 5 plus 3, 8, 8 minus 8, 0. Yes, so one of the root is 1 and the second root c by a. C value is minus 8, a value is 5. Okay? Right. Next one. Next property. Same, but there is a small change in the condition. A minus b plus c. So middle term is negative. A minus b plus c equals to 0. Then the roots are minus 1. Then the roots are minus 1 and minus c by a. Okay, na? That means any quadratic equation should satisfies the condition a minus b plus c equal to 0. A minus b plus c equals to 0. Then the roots of the quadratic equation is minus 1 and minus c by a. Minus 1 and minus c by a. Check. Example. 5x square plus 8x plus 3 equal to 0. I am taking entire quadratic equation is positive symbols. 5x square plus 8x plus 3 equals to 0. Now check what is a value here. Yeah, a value is 5. B value 8. C value is 3. Now check the condition. What is the condition? A minus b plus c equal to 0. A value 5 minus b value. What is the b value? B value is 8 plus c value. C value is 3. Now positive value is 5 plus 3, 8. 8 minus 8, 0. Yes, the condition is satisfied. Therefore, the roots are minus 1 and minus c by a. Minus c by a means minus c value is 3 and a value is 5. So therefore the roots are minus 1 and minus 3 by 5. Okay, na? Same, just here taken the x coefficient is negative, that's it. A minus b plus c equals to 0, where a, b, c are coefficients of x square, x and constant terms respectively. Okay? Now find it here. I am giving the quadratic equation. Just check and find out the roots of this quadratic equation. Okay? Check for this quadratic equation. Minus 3x square plus 10x minus 7 equals to 0. Minus 3x square plus 10x minus 7 equals to 0. Is it satisfying, children? Yes. Minus 3 plus 10 is plus 7. Plus 7 minus 7, 0. Am I right? Check. A minus b plus c. A value is minus 3. Minus b value is 10. And c value is minus 7. All are negative values only. All are negative. So is it satisfies? No. Observe here. The equation having all are same symbols. I am changing here symbol. Okay. Now I am changing 3x square plus 10x plus 7. Now check. Now this will be satisfies the condition and we can identify the roots of this quadratic equation. Okay? Yeah, 3 minus b value is 10 plus c value 7. So 10 minus 10 equals to 0. Then the roots are minus 1 and c by a. What is c value? Is 7 and a value is 3, 7 by 3. Okay? Right. Now we are just applying only the condition, right? But if you do the general method like splitting the middle term, is it satisfies or not? Let us check. That means for this given equation, I am going to find the roots by using the splitting middle term. Okay. Now, what are the rules for splitting the middle term? First, we should multiply the constant term with x square coefficient. Constant term is 3 and x square coefficient is 5. So, 3 5s are 15. Right. For this 15, we should write the possible factors. I know that the factors are 1 15s, 2 table is not coming, 3 5s. 3 5s or 5 3s. So, that is the first condition. Second, while you are adding these factors, you should get the middle term. Now check first factors. 1 plus 15 is 16, but here we got 8. So, first pair of factors is not satisfying for us. Check 3 plus 5. Second pair, 3 plus 5 is 8. Yes, it is satisfies. Now, I am writing as 5x square plus this 8x I can write as splitting this 8x as 3x plus 5x. 3x plus 5x. I am writing first 5x, next 3x. Anything. 5x plus 3x or 3x plus 5x. Both are same, right? So I am writing 8x as 5x plus 3x. Last number is 3 equal to 0. Now see, from first two terms, 5x is a common term. You can identify 5x from first two terms. So still x is remaining, here 1 remains. Again multiply and check. 5x into x, 5x square plus 5x into 1, 5x. Now, second two terms, these two terms, what is the common factor here? 3. Yes, take 3 common, here also x plus 1. Okay, no? Now, up to here one term, 3 to x plus 1 is another term, 2 terms. Again these 2 terms, x plus 1 I can see as a common factor. X plus 1 common factor, then 5x plus 3 equal to 0. Yes, I have expressed the given quadratic expression, given quadratic equation as product of two factors. One is x plus 1 and second one is 5x plus 3 equals to 0. Now, let us equate both of them to 0. X plus 1 equal to 0, then x value is minus 1. And second one, 5x plus 3 equal to 0, 5x equal to minus 3, x equals to minus 3 by 5. Check. Minus 1 minus 3 by 5. With the general method also we are getting the same answer, minus 1 and minus 3 by 5. And by using the condition also we are getting the same answer. Am I right? Yeah. Please note it. Yeah. Okay children. We will go to the next. Right. If the roots are negative, that means both roots, alpha value is negative answer and beta value also negative, then A, B, C will have same sign. A, B, C will have same sign. Check. What are the roots we have here? First one is minus 1, right? Second one is minus 3 by 5. Both are negative only, no? First root is minus 1 negative. Second root is minus 3 by 5 negative. Then observe the quadratic equation. 5x square plus 8x plus 3. That means A value, B value, C value. All are positives only. That is only the condition here given. All are having a same sign. That means all are positive or all are negative we can take. Clear? So that means you have to observe that if alpha and beta are nothing but roots of a quadratic equation are negative symbols, then A, B, C will have either positive or negative. Okay, na? Same. 5x square plus 8x plus 3 or minus minus 5x square minus 8x minus 3. I am just taking example from previous condition. Same I am taking, I am not changing anything. Okay, now? Right. Next, coming to the next one. If the roots of a roots are positive this time, roots are positive. Previous condition is roots are negative, right? If roots are negative, a, b, c, that means all coefficients of x square, x, constant term, all are same sign, whether they can be positive or negative sign. But see here, roots are positive this time, then a and c will have same sign and b will be different sign. That means if a and c are positive symbol, b will be negative. This is one condition. Or a and c are negative, b will be positive. That means while you are observing that quadratic equation, first and last terms are positives, then middle term only, no, b term, x coefficient, middle term will be negative. Or first and last terms are negative, middle term will be positive. Then there is a chance of, not chance, surely the roots are positive roots. Okay? Otherwise, the condition is, if the roots are negative, then the condition is a, b, c are all are positives or all are negatives. Okay? Check. Right. So, yeah, we'll continue that class in our next session. So, thank you one and all. Have a nice day. Bye bye.